Well, hello everyone. Welcome to the broadcast. Today we are going to be trying to get our collision shader uh, set up safely. Right now we have the shader running, but it doesn't handle identifier or resource management properly. Which means at the very least, well, after the last stream, I had to reboot a couple of times. So if we poke it further right from the beginning like this, I expect it to be at least as bad. That might mean that there is a silent intermission for a few times while I reboot or crash. So please look forward to it. Before we go too much further, though, I see we have Strawberry over here on YouTube. Welcome. Train of thought went off the cliff there. Let's check in with the kitties here. We do have Sammy up in the cat tree. She's been up there a little bit more often recently. Ember is on the side of the desk. She's not in her normal spot. Mason on the bed. And then Sherbet and Sky over there in the play area. Sky's been down on the floor a little bit more lately. Running a bit rampant. Okay, let's get back to where we were. So, we're not using that just yet. That. All right. So we have this test here. We know it's working. I'm going to remove that debugging code for now. It's an extra performance burden. We've got it actually going. So what I've done is I've split the shader across two physics updates. I may do this across the board. Switch over to an A-B kind of loop. But especially since this is operating this way. What happens is if the shader is already running, if the last frame we ran it, then we're going to retrieve the data. If it isn't running, we'll skip this. There could be an else here. I should have an else. It's just an else. I just realized that. Anyway. If it's not running, we're going to run it. So we're going to set up our compute list. We're going to submit the shader. We're going to toggle the flag. And this will loop along. Now, at the start, we instantiate an element called a shader collision components. That is the basis for that. All of these RIDs are a problem. Because if these don't go away properly, if we don't release this rendering device and the corresponding stuff, things get bad. Effectively, anything we don't release is going to build up in GPU memory, which, again, is bad. So, and I don't want to demonstrate it too often, because just running it costs us. Also seeing that there is some sort of problem with like tabbing away as far as the device. I don't know what that is. Might have to look into it. Well, we'll have to look into it. But for the testing code, we've got that running. We're doing the thing. Right now we are... Yeah, James has been, James over on YouTube has been doing similar tests, doing shader-based collision with particles and simple movement and such. And they're running into similar issues. One of the things that we're seeing is that there's some sort of error state when the app doing this isn't in focus. So there might be some extra handling that needs to be done here. I don't know. But that's part of the reason that we have this all encapsulated, so if it goes terribly wrong, I can always retreat back to the prior model. I don't want to. I feel like this one is going to give us a lot more control over things. Again, we'll see. Hello, Sherbet. Sherbet is behind my head. Some scratches here. But when this starts up, we set up a shader collision object. When this is instantiated, you give it a path. To instantiate it, you have to give it a path. It's going to create that local shader. We get the shader file, we get the sphere V, we create a shader from it. This is an RID. I need to make sure that we free this as well. We then go through and we're going to create all these buffer entities for the various objects, because we need to have the RID for the buffer to update any information about them. And all of these are going to get updated one way or the other. There is one case that I'm probably going to use that won't. We'll get to that. It's effectively, I want to be able to pass in some of this stuff as internal parameters, essentially, telling it this is how we're operating from the outside so that it can adjust some of its logic. Things like how many collisions there are, max collisions there are, how many work groups there are, influence the logic. So right now, since there are 20 work groups, we have 1,000 local work groups. So the shader runs 20 times in parallel, has 20 parallel instances. Technically, it depends on what the card is capable of. But every card is supposed to be capable of 64,000. That doesn't mean that will perform. But we've got it at 21,000. That seemed to do okay. So each of those 20 will run 1,000 times. Right now, we aren't using that actually for testing purposes. We are just having each shader iterate over a number 20,000 times. So we'll do 20,000 simple math operations, which is approximately what we're doing, what we intend to be doing, is some quick spatial math, and then some quick spatial math, and then recording whether there was a collision. So generally an end level operation, like nothing really tangible, but as far as what's going on in it, but we're doing a full n squared loop here. Every value we're checking it against every other value. For our tests, we are just reading in. We're currently just caring about the collision buffer and collision count, the things that change, or the output values. That's what we're going to be testing on. One of our problems, though, is that this doesn't get cleaned up. And we've tried a couple of things. One of the problems is that this currently will never happen. Despite the fact that we create it, it's stored as a static element, and that static element won't go away until the program is ending, which normally, if we weren't dealing with this stuff, would be fine. But at the Godot level, all of this important stuff isn't going to happen at the end of the program. It needs to happen before the end of the program, when all the Godot stuff is still around, when we can deal with these RIDs. So that needs to happen before. We're going to have a manual trigger for cleanup. That presents its own problem, though, because when we are creating the game currently, this will be one layer out, but since we're doing the right into the game at startup, it does it right away. So we load up the services into the entity manager. We're getting each of these. So let's go into our... we're getting our startup resource. Where are we setting that up initially? It's ready. It's in core. There's a lot of moving parts, so forgive me if occasionally I've got to stop and think on, what was that again? How does that work? All right, so we come into core. This is the Godot app equivalent of, functional main. We are going to get our command line arguments. Right now, we're not using these. This is going to be for... this grants us the ability to do things like unit testing, or at least automated testing. We're not doing that yet, but I have the ability to do it now. We parse those arguments when we load up. So core, get the startup resources, initialize services. Go into services, which is up in core still. Now we're setting those up. We're getting our catalog, our entity manager, our renderer. So the thing that makes things do the things. This is what makes any sort of creatures move around, that kind of stuff. It causes them to. Render draws to screen. There's a lot of song and dance going on in there. Collision manager is what we're playing with right now. That is, when things bump into other things. Inventory is a bit of a... contradicts what I said about the entity manager a little bit, but not for long term. Short term, it does. It does its own thing. It causes spawning to happen of like bullets and whatnot. It should not be the thing to do that. It should just generate the information for that. Because right now, these two things operate in different fashions, and they shouldn't. So we go in, we set them up. So right here, we're instantiating each one of these. What? It's going to return an entity manager object, but... just trying to parse this a moment. We're not storing any of this off. like... Was it working? Oh. Well, I have been derailed. We need to look into this. When are we setting that? So we get all of this. We call initialize on the services. And initialize is going to take that startup resource and do, these are kind of the global level. And then when we're kicking off individual game resources, we're going here. This is the things that needs to change. But hey there, Karuru. Probably not. I was considering doing some power wash here today in order to have a bit of a full cool off session. You know, still stream, but chill a bit. And I was considering calling it, you know, like pressurized liquid cooling or some nonsense like that. Because my brain is going to overheat at least a couple of times during this on top of the GPU. Oh, but hello, Koru. Welcome. Where are we setting these? Because this is doing nothing. Let's look at our entity manager. Our default. Right there. As soon as the scene comes into existence, it sets itself as part of it. Okay. 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 So this is us invoking them and saying, "Hey, this is where they live." I don't know that I really like that. I kind of feel like we should be putting it there. Because this hides it from the code otherwise. Like, when you look at the entity manager's base class, we know that this happens. Like, when we're looking here, we know that happens. But we don't know from the place that's actually storing it off. Right there. So we're instantiating it. We are creating an entity manager object here. It comes into existence, which runs the constructor code. And that constructor code sets the value up here. I don't like that. I don't like that. At some point, I thought that was okay, and now I really think it's not okay. We'll get to why I'm hovering around this in a moment. Okay, we have all those pieces. Now we're going to go into Core Entity Manager, remove that. go into mesh render. Sure we're using the right ones. We need render parent object. Because services is where all of this stuff needs to happen anyway. So collision manager. Log. Then in our inventory. Other stuff could happen. What this will do is on the Godot side, it makes it so that if there is an inventory node, it's called inventory. Otherwise, it will be a Godot kind of numeric initializer, which makes it hard to see what the tree structure actually looks like. Okay, so why we do that? You know, in the services is where we have our dependency structure. If we could actually do hey there, Miles. Welcome. We're just getting started, and part of what I'm doing today involves a bit of a recap because there's a structural thing that I've got to change. Okay, so this stuff is in sequence. Entity catalog needs to exist first. There's a bunch of stuff that happens in catalog that is a reference, and it is universal. As soon as startup resources is created, we can create catalog. We can technically do all of that during the startup here, going forward, because we aren't going to make these nodes go away. In fact, they already weren't going away, and that will help us in a moment. What we need to do is in these parent objects, we are going to make them so this exists to make them globally available, let's say. What we want to do as well is make it so that they're this is our 94th coding stream. We've been doing more and more research offline, but still, 94 coding streams. But yes, welcome, and how you doing? Let's see here. We have this so it's globally available. There is a static class called services. Anything can ask for these different pieces. That way, we have that available. But if we change it to where all of these are singletons, there is never supposed to be more than one, no matter which child type it is. So if I instantiate a shader collision manager, that will be the collision manager going forward. Nothing else will be created. So using startup resources, we can set all of them up. But if I do this right, we won't need to keep the references to them. In the same way. But at the moment, this effectively gives us an instance value. The static member still exists out there. The tree still exists. We can remove stuff from the tree. Hello, normal man. welcome over on the Twitch side. So these give me the equivalent of the instance value in a singleton structure. That is the particular entity that exists that is the one instance that will be out there. That's this one. Okay, let's protected set. Provate. In theory, I could make these read-only values, I think. No, because it's not during initialization. We have to get the startup. It's private set because nothing outside of this entity should be setting them. Yeah, so longer term, I want to make things like the catalog a singleton. This guy. So we are making a Vampire Survivor style game. Do I have a good way to run it without breaking it right now? Yes. Need our standard resource here, default startup resource. We need our collision manager. We're going to switch it over to shape collisions. Save that. Compile the project, run that. This will dodge the make my GPU explode issue. Or it's supposed to. Well, that's strange. Catalog. Game object. Our animation shader. We'll actually be able... no, that's a Godot shader. That's different. Render. Shape-based collision manager. Okay. That means something that I just did caused some damage in here somewhere. Right out the gate. Catalog is not being set. This right here is why I'm not using the shader one at the moment, because this would be burning resources. How did that go away? Base. So this is a packed scene. Instantiating it should create an instance of it. Okay. Cursor, right? That's why. That's why. Okay, we need to stick with the idea of them being actual singletons. We're going to keep that. U and revert U. I figured out what broke, by the way. Okay. And we discard this too. Okay. 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 So right here, when it first comes into existence in the base one, we say the catalog value is this. This is this. This is why these need to become singletons, and that there is a static value in the class that represents the kind of true the true one, and that when one is created, it looks at it and says, is that populated? If it's populated, then we don't do anything with it. If it's not, we set it to us, such that whenever anything is referencing the catalog, it would do like catalog instance kind of thing. Or similar, you know. That way, you're always referring to the one true one. Or the only one. And you can get it from anywhere because it's a static. This is essentially accomplishing that, but in kind of a loopy way. Hello, Sherbet. Okay. Well, let's start this so you can see what we're doing. It's in stress test mode right now. Because we're doing shape-based collisions actually happen. It produces a object, both a blob and a yarn ball, every fraction of a second. It's 60 physics frames a second. So 60 times per second we are creating them. We can grossly increase the number of them by doing 3 at once. Little yarn balls, I think, last like 10 seconds. The blobs are cute, are they not? This will be fun too. This will greatly increase the computational cost here. So this is what we're working with, is standard kind of survivors game concept of we keep the player towards the center of the screen. We have enemies converging or spawning outside of view and moving in. And the player emits bullets that will, impact the enemies. The idea being keep them off of you for as long as possible. Our gimmick is that the weapons are generated from kind of logic parts. If you're familiar with the game Noida, that's our inspiration for this. Right now, these are not like end state things. They're placeholder icons everywhere. But we have 2 3-second waits, and then it will split into 3, and those 3 will split into 3, and they will move in a spiral pattern. So you can see that 6-second wait out to about like close to the edge of the screen, like at the top of this, it's just about at the top of the screen as far as distance. Then they split into a bunch and those start rotating. They have 4 more seconds to live, so they don't rotate for long. We can stress it further. We can actually do it that way. So 3 seconds, it'll split, then 3 more seconds. So now we have another inner ring. The extra split was perhaps too much. So this slowdown right here, prior to 10,000 objects, is why we're doing the more complicated, dangerous collision method. Is I want to be able to have a bonkers number of things happening on screen at once with little to no performance slowdown. So right here, there's 3,000 things. Let's add even more blobs, huh? You figured out the slowdown and the built-in physics thing, Parakeet? What's that? That would make sense. It's an interesting thought. So, Parakeet's thought is that the built-in physics system that we're seeing right here is potentially running into problems when it's, what I'm guessing is that it's doing spatial subdivision. Since this is 2D, it would be things like quad trees, where we partition all the things on the screen into buckets, such that if there's something on the upper left edge of the screen, we're not even going to check if it collides with things on the lower right, because spatially they're in different spots. We have been derailed. We have been derailed, and this is fine. One of these is running when it's not supposed to. Ah, there we go. That was interesting. Okay, so let's look at our project settings here. Okay. Thought there was a setting somewhere for that. It's not in this mess. Layer. We're not doing navigation because that's complex and expensive for what we want to do. Really think it would be in physics. It's if there is spatial location changes happening, there's got to be a setting, or there's somewhere in it it's deciding how many bins to have. I don't know if we can tune it though. What you're witnessing is a classic thing in our coding streams, and that is me saying we're going to do one thing as far as our topic, and then a different idea popping up, or some sort of thing goes wrong, and we spend the time doing the other thing and not the thing we planned. This is to be expected. Okay. We look at our shape collision manager. We are going to create. Oh no, that's actually in the Godot side. In our shape collision manager, I think. Collision areas. Okay, here we go. Okay. Collision area list. This was a sub-optimization because if a collision area in Godot has too many shapes in it, it gets bogged down. If you break that down into fewer shapes, then it runs better, but it still has issues. We have a scene for collision manager still, but you know. Okay, collision area is entirely a code construct, so just have to find where I put it now. Subclass at the top, yes. All right, this as an area to be, which will still have attributes of a node, but I want to specifically try to address it as that. Positioning. We are looking to see if there is a variable that would let us tune how big the collision buckets are. Too small, and there's extra calculation on this part of... No, I ultimately don't think this will actually help. We have tuned it to be that there are fewer objects to check collision for, actually. Because right now, there's actually just a handful of collidable objects. Those objects are very complicated. Run it on the Godot side to demonstrate here. Go over... We have our collision manager. So we have all these collision areas that represent all of the possible things. So you have, like, I can't remember if it's player bullet enemy or player enemy bullet, but collision area 1 here is for type 1, then type 2, and type 3 collision objects. Alright, properties on the collision area. We don't have any, sorry, physics interaction. Spatial scaling. Not seeing a tunable element to that. At least not at this place. Okay. Doesn't mean we're done yet. So we have our physics server calls here. It's not where we would add it, but... Shape. Callbacks. Forces. Might just be the nature of the beast as far as how it's doing that under the hood. But again, I don't know that that would really save us for this, because the things that are colliding as far as the checks are concerned are those objects that we saw up here. So inside Collision Manager, all these shapes here, the 41 shapes or collision areas here, there are 41 objects. And what happens is they have up to 1,000 shapes inside of them. And those shapes are the things that define how the collisions can happen. So if it was just like the standard Godot handling would be the collision area has a few shapes in it. You might have, say, like in a fighting game, you have a whole series of like hurt boxes and similar. If you watch anybody digging into how Elden Ring works or similar games, you can see that some of the a lot of the attacks actually have a series of different like giant spheres that represent where you can get hit by them. Even if it looks like, one sword blade or something like that, there are different pieces of it. And that's effectively what these collision areas are. If we were to go in, say I have 100 shapes per collision area, this will generate way more of them. We're going to have like 400 collision areas. Likely got cat hair in the mouse here. And for those new to the channel, we are a very stream of consciousness channel. I will be saying what I'm thinking as I'm going through this stuff. There is no expectation that you know what's you know anything about code or that you're able to answer the current problem. I wonder if we could get away with a different physics engine here. The shader concept is cool, not gonna lie. Still potentially an option. But there is kind of a wrinkle to that. Yeah. We're still hitting our threshold there. So I think... Yeah. I still think it merits looking, but like I said early on, there is a reason that Collision Manager is a parent type. So we can do exactly what we're doing here. Look something up real quick here. Yeah. I seem to recall there was a spot that I could import that from in a in editor fashion. Like it would try to asset lib top center of the screen. Oh, yeah. Because that's maximum intuitive. Thank you. Look this. primarily for 3D. Is this the one you've poked at, Parakeet? I know we tried it early on. Another one. Oh. Let's start down this road, shall we? Yeah. Then we restart again. Now, what we're doing may not be compatible with this. Run into a bit of that before, but we'll find out. I'm still seeing collisions happen. Three, pause for three, pause for three. I like the seething layers that we get here. Okay, it's comparable. It is better. It is definitely better. But similar issues. It's good when you have no documentation in this. Oh, this is a good opportunity. We're going to take a quick break, and then either advertisements will be over, or we'll maybe poke some of the other ones. All right, we're back. So what if... Well, that's not good. So continuing this pattern, we are going to... we're going to install a couple of the alternate physics engines and try them out, see if we get any further improvements. See if we can get a cat on camera here. Okay, yeah, that one's only 3D physics. Don't know what that ultimately means. Okay, so Rapier is better. It allows us to get quite a ways with our limits here. We'll have to do some cleanup after on it after. Let's change a value here. Go 10,000. So this is Rapier with a 10,000 limit. Doing these both at the same time will increase the number of collisions that can happen, which will strain the system further. Yeah, we plummet. Let's see if we can spot where it slows down here. Okay, at like 7K, it's still slower than we want it to be. 5, it's kind of where we want it to be. But we can strain it further by doing this kind of thing. So if you look, frames per second are dropping. That's because spiral motion is much more complicated than the other motion types. There's a series of extra calculations that happen, and when you have this many things moving, it leads to issues. Which is why we want to tighten up the performance of everything that we've got. Let's find a kitty cat here. Ember's in her usual... Oh, we got a double up in the tree. When Sky lays up there, he's commonly towards the front where Sammy is. But Sammy has been laying up there a little more recently. Sky is actually pretty friendly as far as laying near the other cats. Most of them have particular individuals they'll sit near. Ember will tolerate Sky. Mason and Sherbet will lay together. And Sky will tolerate just about any of the others, at least for a little bit. If you look, there's a distinct separation between Sammy and Sky there. She's kind of ambivalent. All right. So this puts us back where we were. This is okay. So we know up in services that we are keeping a reference. We have the master reference here, which means there is an opportunity for us to do a cleanup operation. So we can go into each one of these. At the moment, what we're going to do is we're going to have a method on the parent class that is cleanup. So we're going to start with Collision Manager because that's the one that we're actually operating with here. And it is hiding collision. Okay. Default, it does nothing. But in our shader collision manager is where we want to deal with this. Components. We want to make sure that that's happening. Okay. So we have a static member that is collision components, which contains all of the trouble bits. Making sure I can see where the shader is. And poke that in a moment here. Just want to finish this thought out. Yeah, okay. We're going to free the shader as well down there. Okay, and then we set up services. It's the Godot equivalent of I am being removed. We need to add that to services. So we're saying if collision manager exists, then I'll clean up. And that collision manager then is going to null out collision components here. And if collision components gets deconstructed or removed, it's going to go in and purge all of the RIDs. Hooray. Okay. So now let's go back into our physics settings. I'm using Rapier, so this should be the equivalent here, number of iterations. We're going to start with the Jolt one as the number of physics iterations here. I'm sorry, the Rapier one, and then we'll do the yeah, we are creating a lot of entities per second here. So under 10,000, it's pretty good. All right, let's do our restart. Okay, we're gonna turn one dial at a time for the time being here. We're gonna try to, do proper science. Similar spot. Have it again. Actually, let's just go all the way down to 1 here. And you can just see the tips of his ears there. It holds steady longer. Let's... Okay. Solver iterations don't seem to have a tangible effect like we want them to. Okay. What's the other one we suggested? Recycle. Trying to recall if we've scaled it, so let's actually do that. 96 is a whole square, which is 16 by 16 because we have a scale of 6. That's the rendering, but spatially we've also scaled up. So let's do 48. Collisions are still happening. Again, this is 60 times a second we create these, and currently it is 18 being created 60 times a second. Okay, one more will push us over the critical line. Okay. Just about the same threshold there. Turn both dials. Okay. don't think we're really getting enough of a impact out of this at the moment. Which kind of puts us back to the start, which is okay. Which is okay. Second here. Finding our edited ones so that we can purge all of these other changes. Those. Those. Okay. Relaunch Godot. Okay. We have made some changes to get the cleanup to go in. So we're going to make our first check here. So in the core, when we are wrapping up, we're going to call services cleanup. And we're going to go into here. Because services is outside of the tree. It is just static, which means everything that's part of it is going to continue to exist during this, in theory. We're about to find out. Because we're going to call services cleanup. And then we're going to call collision manager cleanup, which is ultimately going to call into here, where we're going to null out collision components. And we want to make sure we get here. Now, to verify, well, okay, we've got to make a change in the Godot side. We need to go into our default startup resource, and we need to use the shader collision manager here. Collision manager is shader collision manager. Okay. And now we run. So no collisions actually happen during this. So I'm going to press escape. Okay, we have no error state there. We're going to run from this side. Bit of a lurch at the start. If we do this formally, then at the startup of it, I'm going to build the shader, and then it's so during the actual launch of the app, and ideally I would do like a pre-compile. Fewer physics steps per second will definitely improve things. Okay, we're sitting at 16,000 objects. It is decaying. Okay. They get more expensive to move them. Okay. So we have 20,000 things being spawned at a rate of 36 per physics frame, which can happen at 60 times a second, upwards of 8 times per regular frame. And they are moving in complex ways, and that's every one of those splits that happens is a vector rotation on them. And so we have 3 of them going, and then we tell it to move in a spiral. And again, spiral motion is not cheap. The blobs are spiraling in, and they track the cursor. So blobs actually have one of the most expensive movement types, and that's because it looks for the cursor. Just getting the cursor position on the screen is cheap, but it's converting the position on the screen to what the world position is through the camera. That's the pricier part about it. So we get that, and the blobs move towards that. But they're also moving to spiral in, so they're spiraling in towards that point. Feels kind of good. Okay, let's dial it back. Let it fall off. Does it recover? So we should drop to about... Okay. That's looking pretty good, folks. Quickly gonna check something here. What I was doing is looking at this here. Because it's not GPU 0, it's GPU 1. Okay. 1, we're tabbed away. Now, interestingly, any sort of pixelization is the encoding side of it, dealing with all the noise in the recording there next to me. Because it doesn't have... There are fewer shortcuts it can make during the encoding. It has to update everything constantly because there's all that motion happening. Exactly, parakeet. Oh no, more keyframes. But we're holding steady. Okay. So now we go back in here, and the all-important press escape. Okay, this is a problem. Do you see what didn't happen? This didn't happen. So we're going to need to keep an eye on this. That is available memory. Of the combination of dedicated and shared. Sadly, a lot of graphics cards have limited dedicated GPU memory lately. This number used to be going up back in the day. And then crypto happened, and the number has not been going up. Okay, this should have happened. Why did that not happen? Well, more breakpoints. Okay, that happened. Okay, that is not causing collision components to go away. We are setting that to null. That should go away, right? That should trigger the destructor. Because that's been cleared. So we should go into here. We are never getting there. Okay. We're not hemorrhaging anywhere yet, but it's still possible that there's something lingering. I don't... This thing isn't, so in... This one isn't. This is a local class that we create during the startup of this. This is a node, but it's... This should exit tree a grand total of once right now. But that's the trick, is this is happening. Means the destructor of this is not getting called. Why this not getting called? It has no Godot related elements. Going haywire just yet, so. Missing something in how I've written this. Reading some documentation. Okay, that's only for garbage collection, and that's... I wonder if that can reliably happen at runtime, like when we want it to. So we're just going to force it here. Just in case. So you can explicitly call cleanup on this. Apparently no. Cleanup if it's there. Cleanup will only run if rendering device exists. And if this gets garbage collected, we will call cleanup. Okay. We're going to science a bit here. Okay, that went back down. All right. If we go into our entity manager and set this to 15,000, still, I'm not 100% on just 15,000, but finding mouse cursor. I need to look into ways to do a mouse cursor internal to the app, like give it a sprite. Very pretty. Okay, starts to slow down at 12. Let's give it more of a fighting chance here. It's really busy, doesn't it? It's fun to just watch this happen now and again. There's a neat kind of flow to it. Just for funsies. Start by spiraling out. So because there is not a gate between the yarn ball and the spiral, it will always spiral. So we wait 3, we split into 3. We wait 3, we split into 3. I'm sorry, we split into 9. And then we will circle back in, well, I'm sorry, we will circle along our outward path in this one. So this is a spiral in. It tries to home in on its center point. But because it's coming at the end, the center point is moving. So it spirals towards that center point. You can have even more fun with it by doing this. So again, weight 3 split into 3, then weight 3, then split into 9. And once it splits into 9, it spirals out. But while it's spiraling out, it also spirals in towards the point that it is spiraling spiraling out on. So if we instead do this, be more visible with fewer of them. Just a bit of madness, yes. Pattern's not doing what it should there. Let's make it wait a bit longer there. A little harder to see the weight spiral in because that spiral in is going to be based on the random movement one. So if we start spiraling out, then we are going to remove. Yeah, let's put the spiral in and the blobs. It looks neat. Wait. Okay, so the base movement on the yarn balls is to move in a random direction outward. After 3 seconds, it starts to spiral and splits into 3. Then, after 3 seconds, it stops spiraling and splits in 3 again. So that's why there's this slow drifting pack of them. Why are we doing this? Because we want to see just how hard we can strain this system. Seeing where we hit equilibrium here. Cap it at 15,000? Yeah, I did. 15,000's the cap, and when you're near the cap, you get odd behavior for the count. Because if it's at cap, there will be a period where one projectile that would turn into a whole lot of projectiles does not get to exist. So if one yarn ball doesn't get emitted, then ultimately 81 yarn balls don't get to exist. And so it'll slow down like that. But yeah, we're really stable at 10,000, and that's 10,000 with what should be collision. Okay. Do we still get frames per second? Ramp it up. We do. We get double-digit frames per second at about 20,000 things. It's pretty good. As we discovered a while ago, limiting how splits can happen will be a big part of keeping performance rational here. Okay, 20,000. Onward. Okay. We need to go higher. All right, 30,000, and we're still above zero. We're still above. We're still getting frames per second. And the shader hasn't detonated on us yet. 40. Three, 1, 2, 3, in, out. Yeah, we're using spiral because that puts us closer to what we should expect as far as function. We want to have the ability to have more expensive motion. And another. And real good, folks. Well, I mean, this is looking like a pixelated tornado of madness, but for what it is, it's looking good. That said, good time for a quick break. I realized that I had a button that could make it so that you guys could still see the while I am taking a break. Beverage. All right, 4 frames per second, just under 40K. Can we go higher? GPU hasn't exploded. We'll do some more tests on that momentarily, but I want to strain the system here. $50,000 spiraling. Well, not really 50,000, but you get what I mean. We need to go higher. You know what? Leaps and bounds, leaps and bounds. Well, not that many. That definitely won't work. That's greater than 1. If it hits 1, it's 1 or less. Because I have it converting it to an integer so that it's not flickering like crazy. Right? And 5. Oh, wait. I mean, it's choppy as all get out because it's like 2 frames a second, but I'm genuinely impressed. Oh, wait. We're not testing this properly yet. We haven't actually been testing this properly. Because we need to hit the shader harder if we want this many things. So right now, Shader Collision Manager is making some assumptions that it shouldn't. So we're still passing in relevant information here. Max of 10 per. And we're saying 20 work groups. But if it's 20 work groups and we want 100,000 things, then this is part of why we need to add more to it. But anyway, so right now we're just doing 20,000. We need 5,000, but we can't do 5,000. This can only go up to 1024. So we could add a 5 here, because this is a nested for loop. we are going to try. We're going to turn some different dials here. We're going to say 50. Sorry, 100. Okay. Still not done with the test yet. Because now need to go into the shader. And this number needs to be 100,000. This is a lot of operations happening per second, folks. Oh boy. Okay. Every physics frame, which right now is happening 16 to 24 times a second, but upwards of 60 times a second, up to 8 times a frame, we are doing 100,000 passes on the GPU, and each of those passes does 100,000 simple operations at the moment. While it's running, it is increasing our shared memory by about 0.2 gigabytes. Yeah. A for science. We have completely tabbed off of it. Back. I think we're on to something. Oh, wait. Gotta do the full test. Yeah, we gotta do the full test. We gotta make them spin. Oh, yeah. Okay. It still dips to 1 now and again, which could mean that we dip to seconds per frame. But it does go to 2 now and again, which means frames per second. So I feel like 100,000 things potentially colliding with 100,000 things is pretty good for this. It does not account for all of the intricacies of those collisions, but if we have 100,000 things active in the game at once, I'm fine with it slowing down. Oh, good times. Check. I know, right? What shoddy craftsmanship. Well, okay. So if we want to scale this more cleanly, so that I don't have to keep fiddling with this, we need to figure out a way to ramp the numbers properly. I feel like 1,000 is fine here. We'll stick with that. There'll have to be some song and dance inside of it to know that... I mean, ultimately, it's going to use global invocation ID X. This should iterate accordingly. But it needs to know what the max number is. So we'll start with that. Okay, we need a statistics one. So we're going to close everything else for a moment. We're going to go into our listing here. Is it a descriptive commit name? No, but I don't care. All right, so we've got our shader collision manager and we've got our collision check shader. Yeah, we could operate with that. Well, this will either not compile or... Okay. Did not explode. Science, we're going to try it over here. Errors. Okay. Okay, so now we can increase the number. Okay, we're going to have to make some assumptions here. So the number of work groups is now dependent on the number of entities. So we are going to cause some errors by doing that. Is in that guy. This is the only place that we deal with it normally. So this should be entity manager dot max entities divided by 1,000 and 1 and 1. Okay. So we iterate at 1,000 per work group. Now we can get up to 65,000 work groups, so we've got room to play here. Let's go. Okay, we've hit some sort of terrible threshold. That's fair. Clipping that is fair. How are we going to do this? Manager. Performance. Accidentally closed this. Okay, some concerns there. It's higher than it started at, but there's any number of variables with that. Okay. Hey there, No. Welcome. Okay, that just went wrong. May have hit problem space. Yeah, look at that. Okay, we capped the GPU doing that. Let's go back to 100,000. See if we've actually entered air state or not. I feel like I'm just going to take the win here. You know, because previously I was really I was willing to, prior to shader knowledge here, I was willing to say, you know what? 15,000 is good enough. But we've changed how we're doing this, and I'm moving the bar and saying that 100,000 is good enough. What happens if I do this? Oh, it didn't explode. That's good. But we're really close to seconds per frame. Like, we're sitting on the precipice of it, a little back and forth. So let's try to strain it more. No, we are not adding and removing them yet. That's next. I mean, this is non-trivially complex motion that's happening here. I know a lot of folks that get into things like working with small computers like that, like the Raspberry Pis and what have you. I mean, getting systems such that you can actually cleanly plug in a new addition to it, you know? where it's need more compute power, add another X, as opposed to make a whole new one, you know? Not spiking out of control. We're at 0.4. Okay, let's halt. Back down to 0.2. All right. Okay, now we need actual collisions to happen. Which means we need to be going in here and saying, all right, this is... some of them are. Active buffer is a Boolean. That's, you know, is this one real or not? So we're saying for each of these eyes, first we are going to... Oh, we can't do that. Oh, wait. Had that backwards. We can't do that. Okay, so I have to do this check first. I has to be less than max entity count first. If this fails, it short circuits the end and it closes the condition. The reason I have to do this first is because if I check this one, when this one would fail, yes, the end does what it's supposed to do, but this will cause an invalid memory access error and make everything explode. Okay, so first the entity has to operate. So we are... Active should be nothing but false right now. This should actually speed it up. Yeah. It's... You might not notice that it's necessarily able to go faster here. Let's throw in the spirals. But the important thing to notice is that we are attempting to generate 3 to the 7th yarn balls at a time right now, the little pink dealies. And there's a cap of 100,000. And then we're having them all spiral. For at least a period of time, it was able to hold at above 1 and 2. So let's pull the spiral out of there and see if it jumps back up to 3. It'll take upwards of 10 seconds before a change that we make has a full impact because, well, more than 10 seconds at this point, usually. But let's not handle. Interestingly, all of the rendering and all of the collision handling at the moment is being covered by the GPU. The way the little pink guys and the little blobs move is like the visuals of it is handled as shaders. Yeah. Is there some nuance we could do to it? Yes. It's gonna concerns here. Okay, it's not exploding yet. There we go. But 100,000 is well beyond our calamity case at the moment. Okay. So right now, nothing should be happening here. We are going to... We're going to print the first collision buffer. I do have a Discord. There is a link in the LinkTree that is on my Twitch profile or in the video descriptions. Or off of my YouTube channel banner link thing. Okay, we're going to put a debug print. This will cost us non-trivial performance here. So this is where we get this. We're going to say... Doing that right? Something's not right. We should buffer update down here. And we're not retrieving the data. Wonder, is it still looking? 1 second. Is this still functioning? I think I may have turned that off. Or never updated it. This one? There we go. Couldn't remember my own chatbot macros. This isn't right. We do the sync, but we've got the buffer update here, not... Yeah. It's not running. We need to do buffer updates. Over here... to... Second. I've discovered a flaw. Looking. Buffer get data. Okay. Data is equal to Marshall dot from byte int bytes dot as span to array. Okay, we're doing things to actually retrieve the data. Bytes, data, collisions. Okay. Our shader, and we're setting collisions for I. So this isn't doing fully at all what it's supposed to do, but Sammy has come to sit with me. String. This is not cheap. This part is expensive to do. Especially since we're going to have to run it in Godot to see it. Okay, it's not updating it. Now what we're going to do is try to force it to work properly. Say active data. We're just going to say that 10 is the true one. So then in our debug statement, Sammy is very stubbornly sitting upright, blocking, half blocking the mouse and blocking a chunk of the keyboard. Having to kind of lean around her now and again. So we're getting the first 20 values out of collisions data. Only one of them should have anything in it. What's that? Yeah, this is not cheap to do it every frame, but we doing it. Functioning. From the Godot side. None of these are running. Okay, well, that could be a problem. Wait. Okay, we aren't updating the active buffer. We need bytes for all of them. But we'll do them piecemeal for now. All right, so now we're starting off the active bytes. We have those. And so when we are calling into the shader, we need to update each of the values. Now we're not retrieving active back. We don't need the shader to tell us anything about that. To memory Marshall as bytes. Data as a span. Array. Device. Data buffer update. Buffer 0. It's an unsigned int. It's active bytes. So we're passing it in. Short story idea, huh? No? What's that? Or what's your idea, I should say? I'm aware of the concept of short stories. Hey, still nothing being set. So active buffer. Finding 0. Yeah. Just for science, in case I've got some sort of syntax issue. I acknowledge you, Sammy. Okay, it's not that then. May not chew that. Should be the same thing, but hey, who knows? Okay. Let's verify the data that's going in. Okay, active data 10 is true. Okay. One of the fun cases that the size of the two is identical with booleans and their bytes. Is the bools are 1 byte long, whereas the byte length of like collision count, since those are integers, they are 4 bytes long. So the byte version is 4 times as long. Okay, so the active one is there. Correct, Parakeet. Which is why if you're using a structure of any kind, it being in multiples of 4 is ideal. Your vector 4s, if they're otherwise, they should be able to multiply out to 4. So like 100,000 is okay because it can be in blocks of like 4 bools. That kind of thing. Though actually, when it is passing the data, it tries to block them into 4s. So you never want something that can't go into a 4. It becomes awkward and it will pad it out further. pipeline, we set up the uniform set. The uniform set has our active array, binding 0, our active buffer. It's binding 0. We know active bytes is getting set up properly. Which would imply it's something in here it's not liking. This is binding 0. It is booleans. Right, let us data I. Okay. Godot doesn't like having a shader file there. The Godot editor, I should say. Errors in the bytecode. Yeah, probably. No, I have an extra one. Bonus semicolon. Oh, okay. 2 changed. Why 2? That means that there's some structural problem. So we're going through and saying if the active buffer for a particular one is true, then set it to 1. The third index, just double checking our GPU. Yep, okay. We are, if you look, we're taxing it more here because we're doing some calculations on some more of the data. This is a bigger test. Yeah, we're gonna have to refine that because we're really taxing the GPU with what we're doing. Again, though, it's doing it for 100,000. It needs to, but we do want to cull it down further than that. So why is the second one, or the third one, coming through that way? All right, we are going to try this as an int. Need to make a bunch of changes. Yeah, that's okay, Parakeet. Because right now there's no differentiation. It's okay that they stomp, but it's unclear as to why. So when this runs, the only one that is set to true is index 10. So over and over, index 10 should get set to 1, but index 3 is getting set. Really got to work on our efficiency there. So finding some further balance as far as the work groups is concerned will be one. Yep, I know. It's actually running better on the Godot side. Oh, that's because it's airing out like crazy. Oops, that's not good to do. Okay, though. Some sort of... Oh. There's got to be a place where that's going wrong when we're uploading it. Maybe when we're defining it that it... Ah. Okay, that's catching it properly. Yeah, had to be a proper statement there. It was likely, yeah, GL does care. Well, I wonder if this will work. Let's find out. I think it was what we were talking about, is that we were passing it in a particular format, but by the time it got here, when it wanted a bool, it was actually structured differently. As in, the stuff that got to here ended up in a different layout. Okay, this is working, but now we have to limit it further. We're on a bit of a roll, so we're going to continue here. Nice. Check the shader again here. So we have to be within range, and the relevant active buffer data needs to be 1. So when I hits 10, it should be set to 1. But that's not what we were seeing. Going to do something I shouldn't have to do, but let's make sure. Still no. somehow never reaching that. Like it never gets to this point. But we know that this is actually something that can happen. So let's put it down here like this. This should be the equivalent. That gets set, but it's costing us a great deal to do it. Now, from a practical perspective, we wouldn't really be doing this way. It would be this. So this is still wildly expensive, though. Because we're doing that set really frequently. We only want to mess with the memory if we absolutely have to. So let's do a test of just this part. That would have caused a problem there. It's a bit of a hassle because it doesn't acknowledge the context shift there. There we go. But our performance is potentially going to take a hit. Let's find out. Ultimately, it's not. make it an accurate test. Still holding steady. So one of the things we've learned with this is don't mess with the buffer unless you absolutely have to. If you touch that memory, it's expensive. Yeah. Now the question is, how many times can we do this and not have it go haywire? Zero, 2, 4, 8, and 16. So ultimately, the question is how many collisions per second can we handle? And every collision that happens is 2 writes to the buffer. So we don't really care about this part at the moment, so we're going to cull that out to save this part of performance. Printing to the output is not free. Ooh. Have to look at the syntax for that, but good point. If we had buffers that are read and write only, that will save us. Save us cost. All right, Parakeet. We're probably close to wrapping up, if for no other reason than that my eyes are starting to go. Okay, the equivalent of 50 collisions per frame, and we're holding. Excellent. Well, that's a victory condition to end on there. Good times, good times. So, accomplishments today. We actually did not blow up my GPU. Cool. We got our active entity count up to 100,000. As far as running our collision checks, we got general proof of concept. There's going to be some extra math, but also right at the end there, Parakeet suggested another performance tweak that might help us with it. So we'll see if that expedites things or improves things, you know. All right, folks, but thank you for joining us. If you like what you saw and would like to see more, remember to like, follow, subscribe, all those good buttons. They help the channel grow. And with all that said, I hope the rest of your day is good, and I will see you next time.